I still got to record myself, so we got that. Yesterday I recorded myself, and the video was entirely blank.
Oh.
The audio was fine. I have no idea why. I mean, second period worked fine. Fourth period, like, where am I? There's a big black rectangle in the middle of the screen. So hopefully this is working right. So it's a very visual thing, and it's actually kind of a what I might call a kinesthetic thing. And so I've been actually thinking for several years like how I can turn this into like literally something where you move things around. I just haven't done it yet. And I kind of have something that's quasi-kinesthetic, but because of how we're working right now, it's just not going to work. So it's still going to be kind of visual. It just won't be you performing the actions that I think would be probably best, but that's okay. So we're going to basically review how we write Newton's second law, or NSL equations, for a particular situation. And so many times, and I can remember I was like this when I was first doing this in high school physics, like I thought there was just some formula that I plug into and never quite understood why that didn't work or where these things were coming from. And it's because there's really a whole process to get there. Like you build the equations literally from diagrams that you draw beforehand. And if you try to do the equations without the diagrams, it just doesn't work. But there's all these little details along the way too. So I'm going to try to demonstrate with some fairly simple situations so that when you get to more complex situations, you can trust that the process will work. And you work through that sort of 5 steps, not necessarily formally, but at least in your head you consider all of this stuff. So I'm going to demonstrate with the first one what I mean about all the steps. And we'll see how it goes just drawing here. Making sure I capture what I want to capture on video. And actually, I'll say I'm recording this video mostly for Noah Beeman, who's at home. Not live, but just sending it to him later. If you feel like this is something like, oh, I'd like to look at this again someday, like before an AP test or something like that, I'll have it. Hopefully it actually shows something with video. Okay, so the process, as I call it, is described in these steps here in bold up at the top. And in most of these we went through, I think, it's hard for me to remember last October whenever we were doing this. So here we go. We'll try to follow each step. So we got a calculator sliding leftward across the floor, slowing to a stop. Bad punctuation in that statement there. Sorry. So step 1 is to just draw and label forces acting on the object. So many times, especially the artsy kind of people, want to draw something that looks like a calculator. Don't bother. You can just do that. There's a calculator.
Beautiful drawing.
So step 1, we've drawn the calculator. You could even actually draw a dot. The problem with drawing dots is it doesn't give you a lot of space to draw forces on it, so I actually usually draw like little rectangles. Okay, so then there's like this category or this catalog of forces that you can pick from. But by the time you've done enough of these, you start to get a feel for the kinds of forces that you typically have. So I think as I said it, I would say, all right, there's one force that we always have. I can't think of a problem I've ever done that hasn't included. What force is that? That's gravity. And the cool thing is it always points in the same way, so you don't have to think real hard about it. Although I've seen people point it sideways. Like, oh, I don't want to live on that earth. It doesn't matter what you're standing upon or what the object is, and it's always down towards the center of the earth. That's just how our sphere works. We use shorthand notation like FG is typically gravity. In last year Physics 1, it would say F grav. That was Tom Henderson, who wrote the website. He liked grav. That's fine. And then everything else is just dependent on what is in contact with, literally touching the object. If it ain't touching, it ain't exerting a force. And if it is touching, it is exerting a force. So what will be touching a calculator? Yeah, the floor. It says it was sliding across the floor. So when you have floors or surfaces, you can have 1 or 2 forces. the floor or any surface always exerts a force that is perpendicular to where the surfaces are. So in the case of a horizontal floor, it's a vertical force, and we call that normal force. Normal, the geometric definition of normal means 90 degrees too. So this was the floor pushing up. Again, in physics classroom, it's F norm. That's fine. I don't want to get it confused with somebody named Norman who might be touching the calculator and then it's Norm. The other force that a surface could provide is potentially a friction force. And that can come in two different flavors. So if we actually have sliding across the floor, then we have either, some people call it sliding friction, but more commonly called kinetic friction. So then and if it's kinetic friction, it always opposes the actual sliding of the surfaces. So since the calculator is sliding leftward, like moving this way, I sometimes put these little tails on it just to remind me. Now, I don't want to draw them real prominently because I don't want them to look like forces. Just little tails so that I can tell which way it's moving. Sort of cartoonish, but it works. So which way would the friction force be? Yeah, the other way. Literally parallel with the surfaces. So it's almost like we take the force of the, by the way, that's its abbreviation. It's a subscript. The K is kinetic. And F is friction. But it's almost like we've taken a single force from the floor on the calculator and broken it into two perpendicular components. And some teachers teach it that way. I've never really liked that. I like to think of it as two totally separate things. And they are related to each other. But I've just never seen it where somebody literally drew the force like at an angle like that. I think that would be a bad practice. So don't be tempted to do that. Any other things in contact? Now, there was something in contact. Something had to get this thing moving. Calculators don't just move themselves across the floor. Don't go into past tense and say, oh, well, there must have been somebody like throwing it. They were mad at their calculus test, so they threw the calculus. Forces do not exist once the contact is broken. Okay? So if it ain't present tense actually touching it right now, it ain't a force. So then that would be it. Okay? So good. Step one is done. By the way, all of my rambling makes it seem like this takes a long time, but when you do it in practice, it will be pretty quick. Identify the acceleration direction. Do we know the acceleration direction? Okay, watch out for the phrase slowing, because when something slows, its acceleration is opposite the direction of the motion. So since the motion is leftward, I'm going to draw a little arrow. I'm going to use a different color so it clearly looks different. Doesn't look like a force. And don't draw it on the object, then it's going to just blend in with the force. Again, bad practice. So the acceleration is rightward. The reason we want to know that's a step that you probably wouldn't see that in a typical presentation. It's because step 3 is to choose two directions for your equation. And one of them you want to be in this direction. So every now and then, not on this page, but you could have some acceleration like up at an angle like that. That would be one of the directions you want to write an equation for. For which of that you wanted to write the equation.
I think that made it more.
I always feel like Mrs. Aziz is like standing outside my door. She's listening. For me to end a sentence in a preposition, and she's going to help it. Because as I told you, ending a sentence with a preposition is something up with which we shall not put. What? Okay. So here we go. Step 4. I guess. Step 4 is, again, sort of overkill, but here's what I do. You're going to choose positive and negative directions. Because when you write your equation finally in step 5, you have to get the proper signs on. Here's how you decide the proper sign. That way that you chose in step 2 is the positive direction for that particular equation. So we have a horizontal equation, and I'll choose rightward to be positive. If you choose the other way, it's not wrong, But there's a couple of things you've got to do that most people forget about, and then they mess it up. The other direction, the perpendicular direction, which would be vertical in this case, it doesn't matter which way you choose. So you just choose one. And again, I often will somewhere like designate my positive directions just to communicate to other people as well to remind myself which way I want to do that. Again, so this one is based on that direction. This one is completely arbitrary. I typically choose up as positive because I'm used to that from my math class. Coordinates are typically up for positive. All right, we're finally to like the key step here, which is to write the Newton's second law equation. So there's actually one for each of the directions if you have multiple directions. So the horizontal equation, and then we'll have a vertical equation. Now, here's the visual part. Again, I think the part that's unappreciated. All the stuff, all right, everybody ready? You watching me? All the stuff down here in step 5 can almost be dragged down from the diagram. Don't like make up new stuff. Everything you need is here. So this is why I actually set something up on a computer where I could click and drag things onto the equations. But I'm going to try to, I guess, demonstrate by just a little hand waving. So for the horizontal equation, you find all your horizontal forces. Pretty easy to find when you only have one. And this then comes down here. I'm going to clone it. Control C. Friction force K. Drag it down here. So there it is. I cloned it. Copied it. Watch out for your signs I wrote on here. Because I chose rightward to be positive, I don't really need to write a positive. It's understood. And then any other rightward forces, you would copy them and pull them down. We don't have any. Any leftward forces, you would copy them, drag them down, and call them negative. We don't have any. And that's the sum of all your forces. We call that the net force. Net means sum of all of them, including their directions if you have positive and negative. Easier to say net. All right, and then the last step, if you have acceleration, which look back up here to remind yourself, yes we do, then the other side of the equation ends with ma. I know, it's just a long way to go to get to such a simple equation. Later on, we'll see one where we do have multiple forces. We do have pluses and minuses, and we have to be a little more thoughtful about it. Now, actually, the vertical one will be a little bit more thought-provoking because we don't have just one, we have two. They're in opposite directions, so this I arbitrarily chose. Up is going to be that positive one, so I'll pull it down first. Anything that comes after that that's the other direction will be negative. So again, like hit Control C on this, drag that down. That's how we start. I have no more up ones, so I'm done with those. And then I hit Control C here, I drag this down. But because it's pointed in what I've decided to be the negative direction, I don't say plus a negative, I always just say minus. Most people look nicer. And then once I have all my vertical forces that are drawn here, down here, I'm done with that. Now, look back at the acceleration. Just because there's acceleration one way doesn't mean I have it in every direction. Typically, remember when I went back and I said the reason we're picking this direction or establishing this is because I want one of my equations this way, my other equation to be perpendicular to that. Perpendicular to this, there is no acceleration. Okay? So, I guess we could put m times 0, but that looks kind of weird. You could just put 0. That's not so bad. I more typically will write it this way. Since there's no acceleration, I'll just write a balance of forces. It's just an algebrated version of this. Hello, Mr. McMahon. not like the Grim Reaper called
I
it.
was gonna say, yeah.
Oh, what happened there, man?
What?
Forgot to open his van.
The photo problem? Yeah.
Oh.
Probably.
Do you know what this is about then?
Yeah.
Oh my God. Okay. I don't know.
You get out of the calc place. That's not fair.
Yeah, what the heck?
What the
Maybe
heck,
we'll-
Emily?
We can get another date.
All right, that's not. You know where she is, right?
We can be like, we didn't have a test for a whole week.
All right, so here we go. Now this is as far as I'm going to take it, because then, depending on what the problem is, typically you would have enough information to find, some of these, and then again, like for kinetic friction. These two forces are related to each other. Kinetic friction, mu times the normal force, is your kinetic friction force. That does not work for static, but it will work for kinetic. So again, we just built the Newton's second law equation. Okay. So again, I know that took forever and a day. It's all about the process. Mm-hmm.
So, the horizontal one is the net force, right?
Yeah, the name for this, the name of adding up all the forces, even if there's just one, it's just called the net force.
So, you wouldn't set the
I hope you're never asked for the net force. It's kind of a weird question to
because then
ask.
wouldn't you have net force in the vertical? But I guess it's zero.
Yeah. If you're ever asked for the net force, I guess it could be. You either are going to know these two numbers, which means you can just multiply those and it's equivalent to the net force, or you're going to know like all the forces on this side, and then you just add them up for subtraction, and you get it that way. So I guess whatever information you have.
That only in the horizontal direction, or in the direction.
Yeah, I don't think you'd be asked for the net force in the vertical direction because there is none. Why would you ask for that? Again, maybe if it's a teaching lesson, like reminding you, like, hey, the net force is zero when there's no acceleration. I guess you could be asked that way. At this point, I'd never ask you something like that. Okay. Why don't you try number 2? Again, this will go a lot quicker when we're not running through every step in such detail. So I'd say it's a good practice just to write everything the way I did. Obviously, you don't have little colored markers and stuff. But don't try to take so many shortcuts that you don't know where things are coming from. Yes, so the verb is launching was very important when I wrote that. Instead of was launched. I sure said is being launched.
No.
Yeah, it's clear.
Yeah, no.
Yeah.
Is that an English picture?
Well,
Is being launched way worse.
Look, that's a passive. It's not launching itself. It's being launched by something else. I feel like it's being launched is an appropriate phrase. But I'm not doing it. Picking it over.
So I got a question. So if you choose the positive direction to be the opposite direction of the acceleration, you just need to make sure the acceleration is negative, right?
Yes.
Because I hate having left be positive.
You do? Oh, okay. I get it. I was always that way too. People will forget to put the main.
And that makes sense. That's what I wanted to clarify. Because
Yeah.
I don't want to be.
When we run through this, I'll show that you got 2 different options. Typically, there's something in the context of the problem that tells you which way it's accelerating, but sometimes you can only tell based on your forces. Like if you have one force without something opposing it, Okay.
page on its own, like no subscript at all.
So I know you're anxious. Go up this over to you, but you want to dive into the third one. I built this with a certain sequence in mind. And Wally brought up a really important thing that I want to hit on number 2. So I can stop it from going on to number 3. I mean, it sounds dire, but it's trying to think. Yeah, 3 wouldn't. 3 isn't too much of a stretch.
Writing the accelerated direction helps people. I think that's like.
Yeah. I'll give you about 52 more seconds. Again, it's always a challenge to know how long to give you. Some are ready to move on to number 5, and some are still working through number 2. Oh yeah, there's more. I don't want to run out. Although it's all right, I'm going to stop you there only because I'm afraid of. I don't want to end the period in the middle of this. That's kind of funky. Just reread my sentence. Is launching is absolutely the phrase to use there. I thought the cart was the subject. The spring is the subject. So yes, the spring is launching the cart. Sorry, I thought it said a cart is being launched by the spring.
I don't like all this English talk.
It's important to communicate that stuff, and sorry, we're stuck with English because I don't know Italian. All right, so the spring is launched in the cart leftward, frictionless track. So you can draw the spring, I suppose.
I was going to, but you said don't be an artist.
Yeah, I don't know that you need it. But if it's being launched leftward, I guess after you draw your FG force, that would be the next most obvious force on here. S or spring or SPR I sometimes see, or whatever. So the spring is touching. And then of course we still have a horizontal surface, which means up to 2 forces, always a normal force, perpendicular to the surface. And if, unless it says otherwise, you could have friction. We don't have friction because it says frictionless. Just trying to keep it simple. Okay. Now I would, since there's only one force, we know it must be accelerating that way, so I would call the leftward direction positive. Wally said, I don't like leftward being positive because in math it was always leftward was negative. You don't have to do that as long as you're mindful in the step down here, which way you call positive. And I'm going to call up positive like I did before. So it turns out, vertically, just skipping to vertical because this diagram matches this diagram, so we're going to have an identical vertical equation, still just a balance of forces. Fn equals Fg is my preferred way to write that. And if you choose my direction as positive, then you start with this force. Again, don't choose some different symbol here than what's up there. This is literally copy, drag, if you want to think of it that way. And we have only one, and so there's nothing else to include there. So we would end with the MA. Now, just as an alternative, I hate to even show this. Don't write this because it'll confuse you if you look at it later. If Wally wants to say, no, I want rightward to be positive, then you have to call leftward force. Is that wrong? Rightward is positive, so leftward is negative. So you would have to write negative Fs, it's like 0 minus this, equals m, but then because you know your acceleration is that way, you have to put a negative on your acceleration. That's what people will forget. Well, then just cancel out, you get to the same place anyway. Right. Now, there are times where you don't know the acceleration direction, and it could be that it's negative. What I do in that case is I'll still pick a way to fall positive, and if at the end of the problem I get a negative sign on my A, it means I just picked the wrong way. That's okay. I still know which way the acceleration is. So, so these are our Newton's second law equations for that one. All right. Well, 50 seconds isn't enough to do much else. We'll continue fourth period with. I don't know. It's going to be tight. We'll see. If we get started right away, we can maybe do the rest of it.
We can go.
You want to?
Yeah. We have 8 whole minutes, bro.
That's true.
We can make